Welcome, Principles of Accounting 2 students. Today we're in Chapter 19 of your textbook working on a classic ABC, or activity-based costing problem. You'll notice that these are relatively complicated problems and a lot of you are going to have some trouble doing these. So I want to encourage you to start early, work lots of problems, and get help early and often. Metro has opened not just our existing tutoring center, but the School of Business has offered a tutoring center as well this semester up on the 5th floor of the administration building, specifically for principals 1 and 2 kids. So come on in when you need the help. So let's look at this problem. What we have, very classic problem. Well, except for that, let's just get rid of that. You're going to see a table with some numbers and some blanks, and the first thing you're going to do is freak out. I mean, you don't want to do that. So you want to read this. And okay, traditional cost allocation with ABC. Here we're setting you up. Okay, you attended the course on ABC, which you all did, and you decided to apply it to your company. And so they gave you some costs based on your products. We have 4 products. So part of people's struggles are reading tables. So again, with tables you have columns, you have rows, and you have data in the cells. So here we got 4 products. We've got product A, product B, product C, product D. Now these products, we have something called output. This is how much you're making in a given year or month or whatever the time frame would be. So, let's think of these as beer cans, right? We're producing 120 beer cans, right? That would be units. Each can would be a unit. For B, maybe this is Coors, maybe this is Keystone, maybe this is Schlitz. All the good beers are going to be in here. So these are the number of units that you're producing. Now we have something called machine hours. Now all that is, right, when you produce something in a manufacturing plant, we generally produce things using these things called machines that are eventually going to rise up and take us over. Each unit, and why do I know it's a unit? It's because it says so right here. Each unit requires 4 hours of machine work, which means it's probably not a beer can. It'd be something a little more substantial, but it takes 4 hours of machine working on this mythical unit, which probably has something to do with foxes. I guess it's making electronic foxes. There we go. Your 4 hours to make 1 unit. We have 120 units we have to make. So we know for A, we just intuitively know from all those years of painful math we had that 120 units, 4 machine hours per unit. Let's see, machine hours required. I know I multiply those, right? So that's 0, 8, 480 is what I'm going to say, right? That machine's running 480 hours to make the 120 units. Here, same thing, it's going to be 300 hours. And you just fill these in, right? Here I know it's going to be 160 hours. And here, 1, 2, 3, 60. Hopefully these are right. If not, we're saving the video forever, so haha. Alright, so this is kind of telling you what's going on from a physical standpoint in the factory. You're making these things, which are tangible items. It's costing this amount of time, ticking away the moments. They make up a dull day. And down here what we have is dollars. So this is going to be cost. Now we have 3 types of cost, right? We have direct materials. Now remember, your direct materials are the materials that you can directly tie to a manufacturing process. You have direct labor. Same thing, that's labor that goes directly in. So you could oops, sorry, I erased everything there. We had direct materials. We had direct labor. And these are these 2 manufacturing costs here. We also, in a manufacturing, have things that we can't really determine. We have to estimate. And those are called overhead. And that's what ABC is all about, is estimating this overhead. Now, On something like this, we know it costs $28 to create one unit. And that's direct labor. It's the person that's only working on that unit, and it's costing them $28. Same thing here, direct materials, it's $40 to make one unit. That's just how much materials you're using. You can trace it. Here's $40 worth of material, and hey, that became that unit. Indirect materials and indirect labor is what we call overhead. That would be something like a manufacturing plant. You can't say that $2 of your monthly rent went to something. You can, and you can do it by math, but you can't actually see it happen. So with overhead, we have to estimate, or allocate is the technical term, the cost. So let's take a look. Let's erase all this. So this is kind of what's going on in this table here. We got your costs here. Down below, we're going to have to deal with overhead. Let's figure out what else is going on. The person that writes this, Dr. Holt, likes to throw in all these other things here that help you out. So we talked about total machine hours required. Okay, what are they asking for there? What they're asking for is, well, for product A, how many machine hours do you need? Well, if I'm making 120 units, it's 4 hours, right? That's 1, 2, 3, 4, 80. Why not? Hopefully that's the same number I calculated 5 minutes ago. And if you want, what you can do, because this isn't a test, we have these little handy dandy things. They won't come up. There's a calculator behind me. All right, 100 times 3 is 300. So we could just fill this junk out. And let's actually, okay, 480. 300. I might need a touch screen at some point. This is going to be 160. 1, 2, 3, and that's going to be 360. And all we did is multiply these numbers. Let's get rid of those numbers so there's no witnesses. Okay, production runs required. For production runs required, we actually need to read a little further to figure out what that is. But not much further because it's all right here. All 4 products are produced in production runs of 20 units per run. All right. So if I'm doing 20 units per run, got 120 units for A, and each run produces 20 units. That's going to be 6. When you divide it, so I know here I'm going to have to do 6 runs to make 120 units. Why? Because 6 runs of 20 units, at least last week this worked, was 120. So unless the physical laws of the universe change, that should work out. So if you notice, everything kind of ties to itself too. All right, same thing here. Well, we know 20 units here, blah, blah. Okay, here we need 100 units. And we got 20. Why? Because it's 20 units, that's 5. Yay, 5. Here we have 80 units for C. 20 units per run. 4 runs here. And look at this one, 120. Hey, we already did that math. That's going to be 20. So that should give you these numbers here. And now we have sales order batches required. So this is a little wordy and complicated, but what we're saying here is that we're selling them in groups of batches. We're not just selling one unit. Kind of like a 6-pack, right? You could sell just a beer, but you're selling 6 in a package or 24. So what we have here, products are sold in batches with each sale being for a batch of 10 units. So here, if I have 120 units, 10 batches, I'm going to have 12 batches. Here I'll have 10. Here I'll have 8. And here I'll have 12. Right, 10 units per batch, 120 batches. So that's how you would just want to fill these out because we're probably going to need them later on. Oh, there's my calculator. Okay, get rid of that. Production overheads. Okay, so remember we talked about direct materials and direct labor. Here all this is telling you is that these are your expected overheads. They're not going to just give it to you in a nice, neat, here's the number. Right? They're breaking it down. Okay, here's our overhead. And even some of the more complicated problems, they'll throw direct material and labor in a table like this. And you got to say, hey, wait, that's not overhead. Here it's a little bit easier. So we know the machine department costs, so rent, depreciation, supervision. You can't really tie that dollar for dollar to a product, which is why it's indirect. You allocate it. Setup costs, same thing. Stores receiving, quality control, materials handling, and then all they want you to do is add this up here, which we're going to do somewhere else in a second. But that's going to give you your total overhead cost. And then down here, they're talking about your ABC cost drivers. This gets a little complicated. This is where people's eyes start going a little bit crazy. So you got to bear with us here. We have the setup costs. These are the same things, and we're gonna, using ABC, we're gonna allocate that number, which is this number here, by number of production runs. Luckily, we calculated that already. Okay, we have stores receiving. Same thing. We're going to allocate that 5250 by number of requisitions, all the way down the list. Notice he's a little tricky. Machine department costs don't have a driver. They want you to pick one. Well, which one? Well, if you look at all the drivers, machine hours is probably the most appropriate. Other thing that's important here, and they always set you up like this, they're currently allocating using a single predetermined allocation rate based on machine hours. That means currently all these costs are just being divided by the number of machine hours and then allocated accordingly. What they want to do, their goal of this problem, is to switch from the single driver to your ABC, which should be more effective in tracking your costs. It's just more accurate, you can have better price points, easier to quality control. It's just so much better in every other way, although it is a bigger spreadsheet. And then we have all this junk down here. Number of requisitions raised on stores was 20 for each product. What? Okay. And we'll figure out how to put that in the second. Need that though, right? Because we have requisitions here. Well, this is telling us requisitions. Total number of sales orders was 42. Hey, that's not the meaning of life. That's going to be the total number of sales orders, which is right there. With each sales order being for a batch of 10, so we're going to have to calculate some stuff in there. Okay. All right, piece of cake. So then what I'm going to do, I'm going to get rid of this pen. And what you guys want to do when you're doing these problems is put it into a handy-dandy spreadsheet. So here's our spreadsheet. I'm going to just organize this for a second so it's a little bit clearer. And I'm going to try to shrink that down a little bit, so we can maybe possibly get this all on one screen. All I did is I transcribed this table here, right here. So here's your units. There's your units. I also abbreviated a little bit on my spreadsheet. Direct material cost, direct material cost. Everything's in here. So now we can once and for all. I intuitively put a total in. Sometimes it's valuable, sometimes it's not. So what are my total machine hours? We just covered this, but okay, 120 units and 4 machine hours per unit. It's going to give me 480. And what makes this tolerable in Excel is you can just drag the formula. Number of production runs. So this right here is the data from down here. 20 units per run. So I know I had 120 units. 20 units per run. Sales order batches, same thing. We can take that from down here, and that comes from this data here. Products are sold in batches. So I know that I had 120 units, and if I've lost you, just rewind, because I wrote this all down here about 5 minutes ago on the video. But this gets us to where we were. I'm gonna, just for the heck of it, this may be useful later, it may not. Some of it is just gonna produce garble. And because I'm an accountant, I'm going to go ahead and do that. And you know what? Why not just put a little comma there so I can read that? All right. So then when you drop down a little bit, you may notice these numbers here. All I did was take them and put them in the spreadsheet. Why? Because instead of using a calculator, I can just add them. And now I know, this is great, I know I'm trying to allocate $25,983 worth of overhead across 4 products. Easy, piece of cake. This over here, oh, what's this? These are my ABC drivers, which tie to this. See that? All I did is I took this table and put it there. And the other thing I didn't do, I also I saved some room because I took the machine department costs and the setup costs. All right, so your setup driver here would be machine department, and we're going to do machine hours. Now your driver total, all I want to do is take the total number of machine hours. Now that I have this, actually, I'm going to make this a little bit larger so we can work with it a little bit more. My total number of machine hours. Luckily I totaled that. My setup cost is my total number of runs. You better run! Total number of runs, 21, there it is, production runs. Requisitions, what were my number of requisitions? 80. My number of inspections, do I have that anywhere? Oh, number of runs, sorry, number of runs is going to be 21. And then we have materials handling, which is going to be based on sales orders. And sales orders are going to be 42. Now here's something kind of nifty. This paragraph here, for the most part, this is your check, but it's also kind of redundant. So here we have sales orders executed for material handling was 42, which is there, and how they got that was just by adding these up. So if this was a 35 and that was a 42 over here, I'd be a little confused. But luckily, right, with each cell being for a batch of 10 units, a product was 120. So they're giving us a lot of the information that we need in this paragraph. It's redundant. Yay. Get rid of that pen. All right. Now, what do we have here? Now we want to do the allocation rate. So I know I'm allocating $10,413 by machine hours, which means for every machine hour, and I'm going to go ahead and make these dollars, you're allocating $6.76 of overhead. For setup costs, we have $5,250, and you're doing it by runs. For receiving costs, right? They said you get $3,600 worth of overhead, 80 recs. Every requisition, you get $45 overhead. That's all that's saying. Here with inspection, it's going to cost you $2,100 to inspect for the entire year. And you're doing it 21 times, which means every inspection costs $100. Here you've got the mats handling, that's materials, of 4620. We're going to do that by sales orders, which are 42, meaning of life. All right, so these become your allocation rates for ABC. Now, if you remember in the problem, what they're saying is that we're not doing that yet. Currently, what we're doing is we're doing it based on a single, what do they call it? A single plant-wide cost driver. Okay. And it's going to be based on, now what that means we're taking this entire $25,000 worth of overhead and we're dividing it by our number of machine hours, which is this. Easy to do in Excel. And I actually left a box for that, right? I'm going to take this 25,983, divide it by your total machine hours, and I'm going to make that dollars too, because that's dollars. So what that's saying is for every machine hour, if you're just taking all this together, you're allocating 1687. All right, it works out. Whereas here, for every machine hour, it's 676, but then you have all these other costs. So then, if you come down here, back to the original problem, the first thing they're going to want you to do is calculate a predetermined overhead allocation rate, assuming that overheads are allocated using the single machine hour rate. Oh, hey, we just did that. That's 1687. So here you would just draw in 1687, which all it is you're taking that number and dividing it by the total number of machine hours. Okay. Still with me? Probably not. But what's nice is there's a rewind button on this. You can watch this as many times as you want. All right, using your answer from part 1, calculate total product costs for each product. So what they're asking you to do here is calculate using the single plant-wide driver. So far we're ignoring ABC. Let's go here. And it's asking for total. So this is always the trick, right? They want total product costs. Total cost is direct materials, direct labor, and overhead. Most of our effort's going to be on overhead in the problem, and we forget about direct materials and labor. But I set you up. I set up a little thing here that says, okay, using your single machine hours, we have our direct materials cost, our direct labor cost, our overhead cost. Where'd these numbers come from? These were given in the problem. They're right here. I just drove those down. On this, they're right there. These are your direct costs. How do I get the overhead? Well, for the overhead, here's where we may run out of room. Let's see. Where's my machine hours? Right here. Total machine hours. Remember this, the first thing we calculated, it was right here. Total machine hours required. See, the reason why he made you calculate those, and these are your 4 products, A, B, C, D. There's your total machine hours. Is because now we have to take the $16.87 and multiply it by the 480 hours. And that gives you kind of a big number, doesn't it? But that's total overhead, that's not per unit. So we could do this one of 2 ways. Let's take a look down here. They want total costs. So we've done something wrong here, right? Like, and you can, and I did this on purpose so that your sanity check years go up, right? Because it doesn't make sense that you have $8,000 of overhead costs, but like really small numbers here. So let's look back up at our table. This is $40 per unit, isn't it? Oh, shoot. But this is $8,000 for 120 units. So this is what we call in algebra class, we're comparing apples with oranges, which are delicious, by the way. What we want to do, we want to take the $40 per unit times the number of units. And that's going to give you your total direct materials cost. Same thing with direct labor. We know that's $28 per unit. And we know we did 120 units. Now these numbers are like, okay, at least they're the same size. And logically that makes sense. And I should be able to just do this with these. Let me check F6 times F3. F6, 21, yes. So those are right. Now this one I'm not going to be able to drag, right? See what it did? Here it goes C23 when I dragged it in C8. C23 times C8. When I move it over one, it's looking for D23, so it's trying to multiply that. I don't want it to do that. Times D8. I want it to do D8. So there's something we can do. And if it's a PC, you can hit F4, or you can always just draw them in. See these dollar signs? When you put dollar signs for something, this is going to lock this cell. It's locked at C, which is the column, and it's going to lock at 23. So when I drag it, so same number, C23. When I drag it over one, it's taking C23 times D8. Here is C23 times C8. So here it's going 1687 times 480. Here it's going 1687 times 300. And I can drag that all the way across, and that would be correct. All right, it keeps multiplying that times these different numbers. Hopefully that's not clear. That's relatively clear. It's the coolest trick in the Excel universe. You'll use it 1.5 million times in your lifetime. All right, total cost. That's easy. We just sum. And then I sum here. If you're watching at home and I'm not doing this right, let me know. Okay. But this should be right. So there's a couple neat little things here. Here's how I know I did it right, actually. My overhead here is 25,983, which is this here. If these don't match, you have a problem. It means you didn't allocate your overhead rationally. Like this is really high, you did something wrong. If it's really low, you did something wrong. Because all we're doing in these problems is finding out or figuring out different ways to split this dollar amount. Here we're doing it just based on machine hours. How do we divide up the dinner check? Well, let's do it by number of forks. Okay, and you do it that way. Down here, when we add up all of these overhead costs, they'll equal 25,983. If not, we did something radically wrong. And so one of the things I look for when I'm grading these is, well, do they even kind of know what they're doing? Because if you get like a $4 number here, not even reasonable, where'd you get that from? You're going to lose a lot of points. Whereas if you're, maybe, if this is 6,000 instead of 6074 and it's a little higher, okay, you did a math problem, got it. So then the next problem, they're going to ask us to use activity-based costing to calculate the product cost. So here what they're saying is, forget what you're currently doing. Like this is nice that we're currently running our factory that way. Let's do an as if. What if instead of using the single plant-wide driver, what if we did activity-based costing? This is a typical job that we give junior managers. Here's what it's currently doing. Again, we're just dividing this $25,000 cost up in a different way. So we know direct materials and labor aren't going to change. So you know what, I'm going to cheat a little bit. I know they haven't changed. I've already calculated them. I am just going to do that. I'm going to go ahead and make these dollars. And you notice these all add up. We're okay there. I'm going to go ahead and get rid of decimal points. And let's do that for everybody. Yeah, let's go ahead and do that for everybody here. All right. So then we're going to talk about machine department costs. What do I do? Well, this 25,000 is divided into all these different buckets. Here's the machine bucket of 10,413, which is going to be based on machine hours. We had 1546, which was a 676 allocation rate. So we know we're allocating $6.76 for every machine hour run for product A. Got that? And you know what? We're friends here. Let's get rid of the decimals. Just for now. It's appropriate on a problem. When you have a $3,000 number, the 40 cents doesn't make a whole ton of sense. I'm also going to say, what am I going to say? I'm going to want to drag the 676. I'm going to go in here and lock it in column H. You can also just lock the columns. And that should get me, if I did this right, my total should equal this total here. Because I'm dividing 10,413, or allocating 10,413 across 4 products, I should have 10,413. So there's really no reason to get these wrong other than you're going too fast or you have no idea what's going on. But because the checks are built into the process, which is a beautiful thing about accounting. All right, setup costs are going to be done by number of production runs. What's nice about this, I noticed a trend here. I got machine hours here. I've got production runs right below it, which tells me if I drag this down, this is cool. That should work. Let's see. Actually, I can just drag this down too. 5250, it worked. What did I do there? Okay. So what I did is I took H7 or H17, which is your setup cost by production runs, 250 times C9, which is 6. Now what's nice about that is just right below the C5. C6 is always below C5, which we used in the last problem. So I could just pull the column down. Saved a whole bunch of calculation. All right, receiving cost, 3,600. I got the $45, right? And we're going to do that by requisitions. That one I can't do that way. I'm going to have to manually enter, because here's your number of requisitions, which doesn't... I have to reread the problem later to make sure I'm doing that right, because that doesn't seem very useful. We're multiplying that, and I'm going to go ahead and put, all right, drag that over, 3,600 equals 3,600. I'm doing this right. Inspection costs. It's going to be $100 per production run. So I'm going to take the $100 times, I said times, hold on, I got lost a little bit. All right, equals $100 times the number of runs. Number of runs, production runs. You better run. Now these are smaller numbers. Something went wrong. Oh, I forgot to lock my cell. I noticed though that something was wrong immediately when that didn't fill out. 2,100. I allocated 2,100, 2,100. I'm good. Materials handling is going to be done by sales orders. There's your sales order. Where's my material? Where's my sales order? So if I grab the wrong column, these won't work out. Look at that, 4620. I'm going to go ahead and sum these. I know this works, but I just want to demonstrate. Notice here, I'm allocating the same amount of overhead to here, but the distribution per product is going to be different. And how you find that out is by adding the columns. So if you're using ABC, look at this. Product A's production costs goes down just by adding it up differently, whereas B goes up more. C's goes down, D's goes up more. And this is important when you're really hammering production people to control their costs, and you're assigning all these costs to them that they're not even responsible for. People get upset. But also for pricing, I can lower my price on this, beat out a competitor, sell more of them, make more profit, just because now on paper it looks better. All right. So the answer for 4, actually, when it asks you to briefly, not 4, using activity-based costing, calculate total product costs and cost per unit. So here's your total cost. They want cost per unit. Did they want that for 3 too? They did. They wanted that for 3 as well. So let's do that for 3 as well. We'll do it for both. How do I do cost per unit? I'm going to take that and divide it by units. And then can I drag them? I can. F3, yes. And then same thing here. No, it's going to be C3. So if you're looking here, your cost per unit went from 135 to 131, 121 to 128. Really the same thing. You're just looking at it. Of course, when people want to buy something, they want to buy a unit of it, usually. And that makes you more competitive, because this is a lot more accurate than what this is doing when you start looking at how your factory actually works. All right, well, that's about as long as I like to go on a video. I will let you answer number 4 on your own. Have a good day.